Welcome to the deep dive. This is where we take your sources, the articles, the research, the figures you've shared, and really plunge into them, trying to extract the most important insights and, the fascinating facts just for you.
Hmm.
Today, we're tackling a really interesting slice of the world's climate zones, pulling purely from the materials right here in front of us.
That's right. Our mission today is, well, to unpack the key features of the Savanna climate, which is also known by another name we'll get into.
Okay.
We want to understand the unique life it supports, both the plants and the incredible array of animals, and maybe explore some of the human stories, the challenges, and the potential within this environment. And we're doing this all strictly through the lens of the specific information provided in your sources.
And based on these sources, it's clear right away that this isn't just any climate type. It sits in a truly fascinating spot. It's described right here at the outset as a transitional type of climate.
Yeah.
That immediately sets the stage, doesn't it? It's not one extreme or the other, but somewhere in between. It acts as a bridge, essentially, between two very different zones.
Absolutely.
Yeah.
That fundamental definition provided in the source tells us this climate is specifically found between the equatorial forests and the trade wind hot deserts.
Okay.
So, picture the dense, continuously wet and warm rainforests near the equator, and then picture those vast, incredibly dry, scorching hot deserts further towards the poles, often influenced by stable high-pressure systems and the dry trade winds.
Right.
The savanna climate is the broad band connecting these two extremes. It's where the constant rain begins to give way to a dry season, but not yet the permanent aridity of the desert,
And the source gives it another name, the Sudan climate. Why is it called that? Is it just because it's prominent there, or?
That's precisely the reason given in the text. It's named the Sudan climate because, according to the source, it's best developed in the Sudan where the dry and wet seasons are most distinct.
Ah.
So while the transition between wet and dry happens in all savanna regions, in Sudan, that seasonal shift is particularly pronounced and clear-cut. This highlights that the defining characteristic of this climate isn't just being in between, but specifically having this very strong alternate pattern of seasons.
Got it. So where specifically around the globe do we see this major transitional zone? Looking at Figure 128, the map you've provided, it's definitely not confined to one small area. It covers, wow, vast stretches of land.
No, it's widespread across the tropics, but generally situated on the poleward side. That is, further away from the equator compared to the truly equatorial forest zones. The map clearly shows its main presence is in Africa.
Yeah, definitely.
We see it stretching across the region historically known as the West African Sudan, and then it kind of curves southwards, extending into East Africa, and even reaching down into southern Africa, specifically north of the Tropic of Capricorn. The source explicitly points to Salisbury in southern Rhodesia, which is now Harare in Zimbabwe, as a key example of a location exhibiting this climate type. You can really trace that broad sweep of red across the continent on the map there.
Right, you can see that huge area in Africa.
Yeah.
But looking at the map, it's not only Africa, is it?
Correct. The source also points out its significant presence in South America. Again, if we look at the map, Figure 128, we see two distinct regions there, strategically positioned north and south of the equator, mirroring the general global distribution pattern.
Okay.
These are the llanos of the Orinoco River Basin in Venezuela and Colombia, which are north of the equator, and the campos of the Brazilian highlands, located south of the equator. They appear as substantial areas marked on the South American landmass.
Interesting. So that pattern of straddling the equator but being slightly poleward of it holds true in South America too. And then there's Australia.
Yes, Australia also has a large characteristic area of savanna climate. The source describes its location as being southeast of the monsoon strip, running from west to east north of the Tropic of Capricorn.
Right, up north there.
On the map, you can clearly see that extensive region covering much of northern Australia, fitting that description perfectly.
So it's these large sort of sub-equatorial belts acting as buffer zones between rainforest and desert on multiple continents, Africa, South America, and Australia.
Precisely. And while they all share that core characteristic of distinct wet and dry seasons, the source hints that the climate can vary slightly, even within this broad distribution.
Which makes sense.
Yeah, that makes sense because it's a transition zone. Conditions will naturally start to shift as you get closer to the hyper-humid equatorial forests on one side, or the hyper-arid hot deserts on the other.
That makes complete sense. It's a gradual transition. You'd expect a gradient of conditions. Now, let's really dive into the heart of this climate type. What defines the weather patterns themselves? The source focuses heavily on those distinct seasons we mentioned.
Yes, the defining feature, the absolute core of the savanna climate, is the alternate hot, rainy season and cool, dry season. This intense seasonality is absolutely crucial and fundamentally shapes everything else about the environment, from the plants and animals to human life.
Right.
The figures you've provided, specifically figure 129 with the climate charts for Kano in Nigeria and Salisbury in Rhodesia, perfectly illustrate this dramatic seasonal shift in both rainfall and temperature.
Looking at those charts, Kano, which is in the northern hemisphere, clearly shows its concentrated rainy season happening from roughly May through September. Salisbury, in the southern hemisphere, shows its rainy season occurring from about October through March. That's the hemispheric difference right there, following the sun.
Exactly. The timing of the rainy season is dictated by the movement of the Intertropical Convergence Zone, ITCZ, and the related weather systems that bring moisture. When the ITCZ is overhead or nearby, you get the rain. As it moves away, the dry season sets in. The rain isn't just spread throughout the year, it's packed into that specific, relatively short period.
And the amount of rain varies quite a bit, too. Even within what's classified as savanna, the source gives some specific figures that highlight this variation.
It does. Kano, in Nigeria, receives a total annual rainfall of about 34 inches. Bathurst in Gambia, which is closer to the coast in West Africa, gets more, around 38 inches per year.
Okay.
But then if you look at places like Khartoum in Sudan, which is further inland and closer to the desert fringe of the savanna zone, the source notes it receives less than 10 inches annually.
Wow, less than 10.
Yeah, this stark difference, showing a clear decrease in precipitation as you move towards the drier zones, is exactly what the source means when it talks about that transition zone. You can see the influence of the adjacent desert creeping in.
It also notes that the total annual precipitation in the savanna is less than that of the tropical monsoon climate. So while both have wet and dry seasons, the savanna is generally drier overall compared to monsoon regions.
That's a key distinction the source makes. It affects the intensity and duration of the dry season, and consequently the type of vegetation and agriculture that is possible. Now let's talk temperature, which also has some fascinating patterns. The source gives a general range for lowland stations.
It says they hover between 70 degrees Fahrenheit and 90 degrees Fahrenheit. That sounds consistently warm, even hot.
They are warm, certainly throughout much of the year. However, the source points out an interesting nuance. While the annual temperature range, the difference between the hottest and coolest months on average is relatively low, perhaps around 20 degrees Fahrenheit. It clarifies that this annual range increases as you move further away from the equator. The closer you are to the edges of the savanna zone, further from the moderating influence of the equatorial belt, the bigger the seasonal temperature difference becomes.
And here's where it gets really interesting with the timing of the highest temperatures. The source specifically states that the highest temperatures do not coincide with the period of the highest sun, for example, June in the northern hemisphere, but occur just before the onset of the rainy season. So, using the examples from Figure 129, that would be April in Kano and October in Salisbury. Why is that? That seems a bit counterintuitive.
Yeah, it does seem odd at first. But this raises an important point about the influence of rain and cloud cover on temperature.
Okay.
The period just before the rainy season breaks is often characterized by intense sunshine after a long dry period with minimal cloud cover. The land surface heats up dramatically.
Right.
Once the rainy season arrives, the increased cloud cover blocks some incoming solar radiation, and the process of evaporation from the wet surface and the rain itself actually cools the air down a bit.
Oh, okay.
So the peak heat is reached in that hot, dry, clear period before the cooling effects of the rainy season kick in. It's like a buildup of heat that gets released, or rather, moderated by the arrival of the rains.
That makes perfect sense. The rain isn't just bringing water, it's changing the entire atmospheric energy balance. And then the source mentions there's a distinct drop in temperature during the dry season.
Yes, the dry season is generally cooler than the hot season, especially the cool, dry season part of it. But what's truly fascinating and a defining characteristic of the dry season in the savanna, according to the source, is the dramatic diurnal range, the difference between day and night temperatures.
Oh, the daily swing. The source is very specific and quite striking about this.
So days are hot, and during the hot season, noon temperatures of over 100 degrees Fahrenheit are quite frequent. That's seriously hot.
Yeah.
But unlike humid areas where moisture and clouds trap heat, the dry season skies are often clear. This allows for rapid radiation of heat from the ground back into space overnight.
So it just escapes.
Exactly. As a result, temperatures can drop significantly below 50 degrees Fahrenheit. The source even includes a surprising detail. Night frosts are not uncommon at this time of the year.
Wait, actual frost. In a climate described as tropical and hot, that rapid radiation must be incredibly efficient to cause temperatures to plummet from over 100 degrees R in the day to potentially below freezing overnight. That's wild.
It really highlights the extreme nature of the dry season. Intense solar heating during the day, followed by rapid heat loss at night. This huge daily temperature swing is as characteristic of the dry savanna as the seasonal wet-dry pattern itself. And, it imposes unique challenges on life forms living there, from plants to animals to humans.
Okay, so we have this climate defined by intense seasonality, a hot, rainy season concentrated in a few months, followed by a longer, cooler, dry season characterized by huge daily temperature swings and surprisingly cold nights. What about winds? The source mentions the prevailing winds.
Yes, the prevailing winds across the savanna zone are the trade winds. Near the coast, as they blow on shore over the ocean, they bring rain to the coastal districts, contributing to the moisture supply during the wet season.
Makes sense.
However, over the vast continental interiors, these same winds are described as strongest in summer, but are relatively dry. This reinforces the pattern of the dry season inland. Even when the trade winds are blowing strongly, they aren't bringing moisture to these areas during that part of the year.
And then there's a specific, very notable wind mentioned for West Africa.
Ah, the harmattan, yes. This is a specific regional wind that blows offshore from the Sahara Desert. It's a dry, often dusty wind that can reach quite far south, down to the Guinea coast. And the source notes its local name is the Doctor.
That is such an intriguing and counterintuitive name. A
Yeah.
dry, dusty wind from the desert called the Doctor. Why on earth would it be named that? Seems like the opposite of healthy.
Well, this raises an important question about how people perceive climate phenomena and their immediate physical effects,
Oh.
sometimes prioritizing comfort over, say, environmental impact. The source explains the paradox. The harmattan carries very low relative humidity, often under 30%. In the coastal Guinea lands, which are typically very hot and oppressively humid, this influx of dry air provides welcome relief from the damp air.
Ah, I see.
It
Yeah.
dries perspiration, making the heat feel more bearable, hence the Doctor. It feels like a cure for the mugginess.
Okay. So it's perceived as a relief from the stifling humidity, but the source also details the negative consequences of this wind, right?
Absolutely. While it might offer physiological comfort, environmentally and practically, its effects are pretty detrimental. It dries vegetation very quickly, turning the landscape brittle. It raises a thick dust haze, which significantly reduces visibility.
Right.
And the source notes this dust haze hinders inland river navigation. So it's a wind with a dual nature, superficially beneficial in terms of immediate comfort in humid areas, but fundamentally harsh and disruptive to the environment and activities. It's a complex wind, and its paradoxical name reflects that complexity.
So we have this environment defined by intense seasonality and dramatic temperature swings, especially in the dry season, influenced by winds that can be either moisture-bearing or incredibly dry and dusty. How does this challenging yet rhythmic environment shape the plant life that manages to survive and thrive here?
The natural vegetation of the savanna is absolutely a direct, beautiful response to that distinct wet and dry seasonality we've been discussing. The source consistently describes the landscape as tropical grassland, or bushveld.
And the image in Figure 130 really helps visualize this. It's not a wall of green like a rainforest. It shows tall grass and trees that are quite spread out, sort of park-like.
Precisely. The landscape is typified by tall grass and short trees. The key structural difference from a forest is that the trees are scattered individuals. They don't grow close enough together to form a continuous canopy that covers the ground. This open structure is what gives it that characteristic parkland or bushveld appearance. The grass is really the dominant visual element across vast stretches.
Where do the trees manage to grow best within this landscape, then?
The source notes they grow best towards the equatorial humid latitudes, meaning closer to the wetter areas bordering the rainforests, or specifically along riverbanks.
Makes sense.
Yeah, it makes perfect sense. These are the locations where there is more reliable moisture available, which is the main limiting factor for tree growth, especially during the long dry season.
And the trees that do manage to grow there, even the scattered ones, have a crucial adaptation, don't they?
Yes, they are predominantly deciduous. This is a vital survival strategy in this climate. It means they shed their leaves during the cool, dry season. Why do they do this? To prevent excessive loss of water through transpiration. With water locked up in the soil or unavailable during the months without rain, shedding leaves is the tree's way of hunkering down and conserving the precious moisture it has.
Like many trees in temperate climates shed leaves in winter to cope with freezing temperatures and lack of liquid water, these shed them in the dry season to cope with drought. It's a different trigger, but the same purpose, conserving resources in tough, dry conditions. The source mentions acacias as a common example.
Acacias are iconic savanna trees, recognizable by their shape and often their thorns. The source mentions that acacias often have broad trunks with water storing devices. This is another adaptation to the dry season, the ability to store water in the trunk itself.
And they're mostly thorny or bushy.
Yes, this is another prevalent adaptation. The source notes thorny scrub becomes common where the savanna transitions towards the desert. Thorns serve multiple purposes. Defense against the many grazing herbivores we'll discuss soon, but potentially also reducing the total surface area of leaves, thus reducing water loss. What's fascinating here is how many different species use thorns as a key survival feature in this challenging environment. The source also mentions mealie, mulga, and spinifex grass in Australia, which are often tough and thorny, again reflecting adaptation to semi-arid conditions.
And what about the grass itself? It's such a dominant feature.
The grass is absolutely central to the savanna ecosystem. The source notes its height varies considerably depending on rainfall. It can be tall, reaching 6–12 feet, especially closer to the equatorial areas with more rain.
Wow, tall grass.
But it decreases to short tussocks or tufts as you move towards the drier desert fringes.
That variation in height across the landscape is a visual representation of the rainfall gradient we talked about earlier, isn't it?
Exactly. It's a clear indicator of how much moisture is available. And the grass itself has impressive adaptations. It grows in tufts rather than a continuous carpet. And critically, it has long roots that can search for water deep in the soil during the dry season. Its life cycle is completely synchronized with the rain. The source describes it appearing greenish and well-nourished in the rainy season.
Full of life and energy.
But then as the rain stops and the dry season takes hold, it turns yellow and dies down. The source says it lies dormant throughout the long, rainless period. It looks dead, dry, and often becomes fuel for fires. But the roots and the base of the plant are very much alive, simply waiting. Then, miraculously, it springs up again in the next rainy season with the first significant rains. This cycle of rapid growth, dormancy, and quick regeneration is fundamental to the savanna ecosystem's survival and defines the rhythm of life here. It's the primary energy source for the animal life.
Speaking of animal life, Africa's savanna is legendary, often called the big game country in documentaries and conservation efforts.
It certainly is. It's home to an incredible abundance and diversity of large animals. The source mentions that thousands of animals are tracked, captured, and seen in films, highlighting just how iconic and numerous the animal populations are here compared to many other biomes.
And the source conveniently breaks them down into two main functional groups based on their diet.
Right, the grazing-eating herbivores, which are the plant eaters, and the fleshing-eating carnivorous animals, which are the meat eaters that prey on the herbivores.
The herbivores are the grazers and browsers. The source lists classic examples like zebra, various types of antelope, giraffe, deer, gazelle, elephant, and the more elusive okapi. A stunning collection of large mammals.
And the carnivores are the hunters, equipped to take down those large herbivores. The source lists lion, tiger, leopard, hyena, panther, jaguar, jackal, and lynx.
A fearsome list.
It's worth noting, as the source does implicitly through its examples and the general food web, that the carnivores are fewer in number than the herbivores. This makes ecological sense. It takes many herbivores to support a smaller population of large predators.
It's a constant high-stakes dynamic between predator and prey. The source talks about adaptations these animals have for survival in this open environment.
Many herbivores, for instance, are well camouflaged. Their coats often blend remarkably well against the dry yellow grass and the dappled shade of the scattered trees during the long dry season, making them difficult for predators to spot.
Right.
Giraffes use their incredible height not just for browsing leaves, but also to spot approaching enemies from a distance. Elephants rely on their sheer size and strength for defense. The source generalizes that these animals are well equipped to venture into the open country, which implies adaptations for speed, endurance, sensory perception, and often living in herds for protection.
And the carnivores are, of course, equipped for the hunt.
They possess powerful jaws and teeth, built for capturing and killing prey. The dynamic between these groups is central to the savanna's ecosystem. The herbivores are the food base, and the carnivores regulate their populations. This raises an important question, really, about the balance of predator and prey in this environment. How do their populations fluctuate with the seasons and available grass? What happens when drought impacts the grass, affecting the herbivores and subsequently the carnivores? It's a system built on tight interdependencies, constantly stressed by the environmental rhythm.
It's a vivid picture of life perfectly adapted to the seasonal extremes. Now, let's shift to the human dimension. How do people live in and utilize this challenging but potentially resource-rich environment? This source gives us two specific examples in Africa that highlight different approaches.
It focuses on two contrasting ways of life found within the African savanna, that of the Maasai people and Hausa people.
Let's start with the Maasai. The source describes them in Kenya and Tanganyika.
The source identifies the Maasai primarily as pastoralists. Their entire way of life, their culture, and their economy revolve around raising livestock, particularly cattle.
So they are herders first and foremost. The source says they have limited cultivation.
Yes, their involvement in farming is minimal compared to their focus on cattle. They grow only small amounts of crops like millet, bananas, groundnuts, and some vegetables.
Yeah.
Their priority is clearly their herds.
And the source highlights something particularly interesting and culturally significant about their relationship with cattle. It says the number of cattle is more important to the Maasai than their quality, and they will not willingly sell their cattle. This is very different from how livestock is viewed in many commercial agricultural systems, isn't it?
It absolutely is.
Yeah.
This points to a deeper cultural or social significance attached to cattle beyond mere economic units for meat or milk production. Cattle numbers might be tied to social status, wealth accumulation, or traditional customs like dowry. The unwillingness to sell suggests they are valued for their own sake within the community, not just as a commodity for the market. This traditional view provides crucial context for understanding their approach to the environment.
Because they rely on grazing their cattle across the landscape, the source notes they require a large area of land which they occupy per cattle.
Yes, extensive grazing in a seasonal environment means the cattle need to move to find pasture, requiring large territories. This also leads to their way of life interacting with others, as the source notes they live side by side with other African tribes who practice cultivation.
The source also touches upon attempts by external bodies or governments to change the Maasai's practices.
There have been efforts, as described, to encourage them to adopt more modern livestock management techniques, such as care for their animals properly and raise them for sale, potentially focusing on improving the quality of their herds and managing pasture more intensely.
Right.
However, the source notes the challenges in this, stating that while many Maasais respond to modern techniques, the majority stubbornly continue in their old ways.
So, tradition, cultural values, and established ways of life play a significant role and can act as a barrier to adopting new development approaches, even if those approaches are intended to increase economic productivity. It illustrates a classic tension between tradition and modernization.
Absolutely. It's a reminder that human interaction with the environment is filtered through cultural and social systems. You can't just impose change easily.
Now let's look at the second example the source gives us, the Hausa. They seem to have a very different approach to living in the savanna.
The Hausas are identified as a large tribe of settled cultivators in northern Nigeria, specifically on the Bachu Plateau. They are a much larger group than the Maasai example, numbering about 6 million according to the source.
And the source describes them as more advanced in their civilization and ways of life than many other African Negroes, and notes they live in towns or villages.
Yes, this paints a picture of a more settled, arguably more urbanized society, compared to the pastoral, often more mobile, lifestyle of the Maasai. Their capital city, Kano, is mentioned with a significant population of 135,000, and a history focused on trade routes, indicating a long-established, complex society built around commerce and settled life.
Their cultivation method is also described in a way that distinguishes it from purely shifting cultivation.
The source explains they clear a piece of land and use it for several years near their settlements. This suggests a more permanent or semi-permanent attachment to specific plots of land.
Okay.
When the soil's fertility starts to decline in one area, they rotate crops between different land parcels and clear new plots nearby. This indicates a strategy for maintaining productivity from fixed settlements over a longer period, rather than constantly moving to entirely new areas every season or two after exhausting the soil.
What sort of crops do they focus on?
The list provided in the source includes millet, guinea corn, groundnuts, bananas, beans, and cotton in some areas, along with other general food crops. Their agricultural base is quite diverse, unlike the Maasai's limited cultivation efforts.
And they seem to manage soil fertility more actively than just letting it rest for long periods.
Yes, the source notes they use manure on older plots to restore fertility, and, importantly, mentions that some use advanced agricultural techniques. This suggests a more conscious effort to maintain the productivity of their farmland, contrasting with the extensive grazing land use of the Maasai.
They keep livestock as well?
They do keep domesticated animals like cattle and goats, similar to the Maasai, but the source clarifies that it's primarily for milk, blood, meat, but the primary focus is crops.
Right.
Livestock mainly serves to support their agriculture, notably by providing manure for the fields. Villagers also raise poultry like chickens.
So, for the Hausa, livestock is integrated into a farming system, providing inputs and supplemental food rather than being the main economic or cultural driver. Their farming calendar must be strictly governed by the savanna's wet and dry seasons.
It is, absolutely. The source uses the Kano example again to illustrate this precise relationship. The farming season for the Hausa is described as closely related to the season of rainfall. Since Kano's rainy season is from May to September, that dictates their agricultural year.
Okay.
They sow seeds late April with first rain, right at the beginning of the wet season. They weed with hoes during the rainy period when the crops are growing rapidly, and they harvest in September when rain stops, utilizing the end of the moisture period.
It's a rhythm dictated entirely by the sky. And what about the dry season? The rest of the year, what do they do then?
The dry season, from roughly October to April in the Northern Hemisphere savanna, sees different activities. The source mentions bushfires are used to prepare the land for the next season.
Bushfires.
Yeah, this practice clears dried vegetation, but it also, requires careful management to avoid negative impacts on soil or wildlife. The dry season is also a period for other activities like trade, building, and social events, since farming is largely paused.
So we have two very different but distinct human responses to living in the same climate zone, as described in the sources. The Maasai focused on pastoralism with strong cultural ties to their cattle and some resistance to commercialization, and the Hausa settled cultivators with more developed agricultural techniques integrated with livestock, built around towns and trade.
It clearly shows the diversity of human adaptation possible within the constraints and opportunities of the savanna climate, utilizing its resources, grass for grazing, or soil and seasonal rain for crops in fundamentally different ways, each with its own set of challenges and a unique relationship with the environment.
Which brings us neatly to the problems and prospects for development in the savanna based on the source's analysis. It's evident from the seasonal extremes and soil descriptions that this isn't an easy place to live or develop, is it?
No, the source is quite clear about the significant difficulties faced in the savanna. One problem mentioned is the low population density in some areas, which can be both a result of the environmental challenges and a challenge in itself for mobilizing labor or developing infrastructure.
And looking ahead, especially with potential population growth, the source points to the fundamental need for greater food production to support more people. But the climate itself creates major hurdles.
The climate extremes are significant constraints. We have the extreme heat we discussed, particularly in the hot, dry season, and then there's the variability of the rainfall, leading to the potential for both crippling droughts when the rains fail or are insufficient, and damaging floods during intense downpours in the wet season.
Both sound bad.
Yeah, both extremes stress agriculture and human settlements.
Health is also a major, often devastating problem in many tropical regions.
Absolutely. Tropical diseases are a major barrier to both human well-being and economic activity. The source specifically highlights gungana, or sleeping sickness, carried by the tsetse fly in Africa.
Ah, the tsetse fly.
This disease is particularly insidious because it affects both cattle and people, simultaneously debilitating the human population and decimating the livestock base that many communities rely on. Eliminating or controlling the tsetse fly is a huge development challenge.
The rainfall, which is essential for the wet season, is also presented as a challenge in itself.
Yes, the source describes the rainfall as low and erratic, especially emphasizing the 20-40 inches per year range as being borderline. What makes it challenging isn't just the low total amount compared to, say, a rainforest, but the erratic nature, the unpredictability of when the rains will start, how intense they will be, and how long they will last.
Right, hard to plan.
Exactly. This unpredictability makes rain-fed agriculture incredibly risky, highlighting the dire need for adequate irrigation if stable high-yield farming is the goal. The source reiterates the comparison to the tropical monsoon climate, which generally has higher and potentially more reliable rainfall, making the savanna's rainfall a distinct limitation.
And even when there's enough water, the soil itself can be problematic.
Many areas in the savanna have poor lateritic soils. The source explains why these are poor. They are hard to work, often becoming brick hard in the dry season, and fundamentally infertile.
Infertile? Why?
Well, this infertility is due to heavy rain causing leaching during the wet season. Leaching is the process where essential plant nutrients like nitrates, phosphates, and potash, the building blocks for plant growth, are literally washed away down through the soil profile beyond the reach of plant roots by the heavy seasonal rainfall.
So the very rain that allows things to grow also strips the soil of its nutrients. That's a significant paradox and challenge.
It is. The soil hardens when it dries and loses nutrients when it's wet and unprotected. The source warns explicitly that under poor management practices, crop yields are bound to decline in these soil types, meaning you can quickly degrade the land.
Raising cattle, even aside from diseases like sleeping sickness, also faces specific hurdles mentioned.
Yes. The source notes the difficulty of successfully raising non-native, temperate breeds like English Shorthorn, Frisian, or Guernsey cattle. They are generally not well adapted to the unsuitable temperatures and diseases of the tropical savanna.
So you need the right kind of cow.
Pretty much. Tropical zebu cattle, on the other hand, are more successful because they have evolved adaptations to cope with the heat, humidity, and local diseases.
And from an economic standpoint, exporting beef or milk from tropical grasslands globally is so far not important, according to the source.
This points to existing limitations, potentially in infrastructure for transport and processing, disease control measures on a commercial scale, or perhaps market access and demand. It indicates that large-scale commercial livestock production for export is not yet a major feature of savanna economies, despite the vast grasslands.
And we can't forget the human element, the cultural and social factors influencing development. The source reminds us of the resistance to change.
The source reiterates the example of the Maasai's cultural resistance to selling cattle for the commercial market, stating this will pose many difficulties for external efforts aiming to develop a commercial meat industry in these regions. It highlights that development isn't just about overcoming environmental or technical problems, it's also about navigating deeply ingrained cultural practices and values.
So that's a substantial list of problems: climate extremes, disease, poor soils, erratic rain, technical challenges in livestock, and cultural resistance. But the source doesn't leave it there. It shifts to talk about the prospects and potential for development.
Despite the daunting challenges, the source concludes on a more optimistic note, stating that the savanna holds great promise for the future, particularly emphasizing its potential as an agricultural region.
What makes it promising? What are the opportunities the source identifies?
The potential lies in the cultivation of specific tropical crops that are well suited to the climate if the challenges can be managed. The source mentions specific examples of crops that have shown success or potential: cotton, cane sugar, coffee, oil palm, groundnuts, and various fruits.
So the right crops, combined with overcoming the limitations, could unlock significant productivity.
Yes. The source also points to human ingenuity and historical precedent, noting that pioneer settlements in Central Africa, Northern Australia, and Eastern Brazil have demonstrated the potential for successfully settling and developing these savanna areas, proving it's not impossible.
And governments are actively involved in trying to realize this potential.
The source highlights the efforts by newly independent states in Africa, specifically mentioning Kenya, Uganda, Tanzania, and Malawi in large-scale production of cotton and sisal hemp. This indicates a strategic focus at the national level on leveraging the savanna's climate and land for cash crops that can contribute to their economies.
There's also potential in different elevations within the zone.
The source mentions potential in cooler highlands found within the savanna zone for cultivating new cash crops that might require slightly lower temperatures or different conditions than the hotter lowlands. This adds another dimension to the agricultural possibilities.
But the source is clear that realizing this promise isn't automatic. It requires specific efforts.
Absolutely. It stresses the critical need for progress through developing improved crop varieties, crops better suited to the specific savanna conditions, resistant to drought or disease, and applying scientific farming techniques. This is about applying knowledge, research, and technology to overcome the inherent limitations of the climate and soil, maximizing yields and sustainability.
And cattle development isn't being ignored as part of the future potential either?
No.
Yeah.
While exporting beef isn't currently significant, the source points to Queensland, Australia, as a major tropical grassland cattle-producing region. It notes that centuries of progress in cattle ranching there demonstrate that large-scale commercial cattle raising can be successful in this climate type with sustained effort.
Okay, so there's a model.
Yeah, a kind of model. To
Wow.
achieve this elsewhere, the source emphasizes the need for specific improvements. A better network of communications for transport and market access, scientific breeding and disease control, to overcome health challenges like sleeping sickness and heat stress, and actively improving grass quality through pasture management.
So infrastructure, technology, scientific knowledge, and better management practices across the board are key to unlocking the savanna's potential, whether for crops or livestock.
Precisely. The source presents a picture where the environment offers potential resources, but it requires significant human intervention, knowledge, and investment to make them reliably productive and sustainable.
However, the source also adds a note of caution right at the end about the environmental risks inherent in developing these grasslands.
It warns that savanna grasslands can be disastrous if they revert, implying degradation or desertification, particularly if they transition back towards harsher Sudan climate patterns due to mismanagement or climate shifts.
Right, it could get worse.
And it also reiterates the fundamental environmental vulnerabilities we discussed.
Yeah.
The rapid soil deterioration during the intense dry season, leading to erosion, and the leaching of nutrients during torrential downpours in the wet season. These remain constant threats that must be carefully managed.
So the promise is there, the potential exists, and some successful examples show it's possible, but so are the significant hurdles and environmental sensitivities. It's a complex picture of adaptation, potential, and ongoing challenges, all fundamentally rooted in that dramatic, powerful cycle of wet and dry seasons.
Exactly. It's an environment that demands specific, often ingenious adaptations from all life forms within it and requires thoughtful, scientifically informed, and culturally sensitive strategies from humans seeking to live in and develop it sustainably for the long term.
Wow, that was a deep dive indeed. We've explored the savanna's defining seasonal rhythm, the unique plant and animal adaptations perfectly tuned to that cycle, and the varied ways humans have lived in and thought to develop this challenging environment, contrasting the pastoral Maasai with the settled agricultural Hausa. We also looked at the significant problems and the identified potential for the future, always referencing the sources you provided.
It's clear that it's a landscape of stark contrasts and incredible resilience. The way everything is tied to that intense wet-dry cycle is truly remarkable.
Based on everything we've explored from these sources, the powerful influence of the wet and dry seasons, the specific soil conditions, the adaptations of life, and the aspirations for agricultural development, despite the hurdles, what stands out most to you about the savanna and the life it sustains?
For me, I think it's that tension between the apparent harshness of the climate extremes, the long dry season, the hot days and cold nights, the erratic rain, the poor soils, and the incredible abundance of life it supports, and the potential for human productivity the source identifies. It seems like life and potential are constantly battling against the environmental limits imposed by that seasonal cycle.
That tension is a key insight. And the human attempts to thrive there with different strategies facing different challenges really highlights how interconnected environment, culture, and development are.
Absolutely. The story isn't just about the climate. It's about how life adapts to the climate.
So as we wrap up this deep dive, thinking about those lateritic soils prone to leaching and hardening, the unpredictability of that essential seasonal rainfall, the constant threat of diseases like sleeping sickness, and the aspirations for large-scale agricultural development discussed in the sources, what are the biggest questions that arise for you about the long-term sustainability of human life and agriculture in the savanna climate? That's something for you to consider based on this material.
Indeed. Given those fundamental environmental constraints and risks detailed in the sources, especially the soil limitations and erratic rainfall, can intensive agricultural development truly proceed sustainably without fundamentally altering the ecosystem or requiring massive external inputs? Or does the long-term success of human life here ultimately depend on finding ways to thrive within the inherent limits of the savanna's natural rhythm and characteristics? It's a critical question suggested by the problems and prospects laid out in these sources.
A truly thought-provoking question to leave you with. Thanks for joining us for this deep dive into the savanna. We hope unpacking these sources with us gave you some valuable insights.